Welcome to Jackal DIY and Tech. As you can see, I have some contraption in front of you. It's quite big as a 27-inch monitor, and what it is a digital and techie installation. It's an interactive one. I'm in the final stages of building it. I'm still missing the top section where a monitor will stand, and that's pretty much it. And hopefully everything will work as intended. Here I'll have a hand scanner that is detected with an aluminum foil from underneath. I could have and should have made this a lot easier on myself and just use some kind of a button. I also implemented this HDD motor, but as you can see, this too does not spin smoothly, so I opted to just leave it in but not have it functional. I then have 5 basic buttons. These work as intended. And lastly, the point of this video will be the trackball. So it's a custom trackball. As you can see, it's using a cheap mouse. So the cheapest mouse that I found was this one. Nothing special, it's quite tiny, but it does the job. As for the ball, I'm using a billiard ball, so a cue ball, a white one, and it does move up and down and left and right. Though in this case the left and right is reversed, so in that case you can use something like Sakasa mouse app, and this just allows you to reverse the axis. In this case I would reverse the x-axis. This mouse is reversed on the x-axis, but this one will work just fine. Well, at least as intended. Maybe just a sneak peek under the hood. This is how I've put the mouse into place. And also, it's not just a trackball, it's actually a clickable mouse. So you can actually click this in. That's why I had to fasten it down with some screws. This PCB is a mess. Initially it was intended to be just a 5-volt power supply for all of the LEDs and any other board that I would use. But then I decided to use the HDD, so I connected also a chip to it, which was the LM393. It did work, but not to my satisfaction, so basically I scrapped the idea. Maybe the most important thing from this project, or of this project, is the hand scanner. So basically I have cut a section of the monitor frame out, because otherwise it would interfere with the detection of the aluminum foil. It still does to some degree, because I can still touch, well, basically the frame or the HDD motor or the platter, and it still detects as if this was activated, which is not. But I already have a video on how to make a touchless sensor like this one. The one thing that I did notice is that it depends on how many samples you have and what the threshold will be. But then, depending on the application and what you have, and also which microchip you use, then it may start to get a little bit sluggish. So in this case I'm using just 25 samples. Oh, so you can also double click. I did not intend on using this as a double click, but you can. And let me load all of the cool profiles that were made for testing. Et voila! So this would be the actual project. And here, instead of using the disk, because it's well not functioning as intended, so it barely spins, and even when it did not send the characters out as soon as one would expect. So maybe it spins just a little bit and it would say, well, it's spinning right or left. Not the case. So what I decided to do is just use the trackball, so you can now scroll it to the left or to the right to select the characters. And now let's get to actually building the said mouse. So at the moment this is my setup. What you see here is basically a stator from a water pump, and it has these nice plastic bumps, so the ball can actually slide nicely on top of it. Now ideally the ball would sit a little bit deeper than it currently is, so that you can't really lift it up. So you can't lift it up like so. Why I decided to use this stator, basically it's something that I had on hand. It has 3 dimples inside. So this will be something that I put screws through, which will hold this in place. I also found 3 rubbery things that I will put, I think something like so. So the screw will hold this in place and also go through the rubbery bit, which does have a hole. And what that will allow me to do is simply put that like so, screw everything down on a piece of plate and put a button below the plate, so this will actually then allow me to click the mouse. It doesn't move a lot, but it will be enough to make this into a clicking button, which I'm not sure if this is something that trackballs actually have. But now the main question is, does this actually move the mouse? I have a mouse right here. You can see the mouse pointer on the screen in the middle of it, just below the fingerprint. So I will simply take the mouse like so, put the ball on top and see if it actually moves the mouse pointer, and if it does, how smoothly does it actually move. And we did see some movement, but not a lot. And it's pretty much inconsistent, so this is not very useful. What I can do is put some markings on the ball with a pencil, something like maybe geographical high points of a map. So something like this, just a bunch of lines, so the laser can differentiate between different points. Usually a trackball has tiny dimples or imperfections, so that the laser can bounce off of. So now I will use these lines to control the laser. Do I have any luck? Not really. Maybe it depends on how far away it is. That could be it. It does work now. So it's not touching the plastic. So because the ball is concave, I believe, it's not exactly flush with the mouse housing. So it gets a little bit closer to the laser than what it's supposed to be, but otherwise it does move. But if I use just this side that does not have any pencil markings and use the same method, it does move a little bit. So maybe this would also work, but because the surface is, well, inconsistent, most of the time the mouse does not move. But in any case, to have the same kind of a theme as this project, which is fingerprint, I will now simply wipe this off with some rubbing alcohol and try to get rid of everything, so the grease from my hand. Use an alcohol marker with a small tip and make some fingerprint kind of looking lines. Now I could just use the pencil, but if I leave it as is, then the pencil will eventually fade out and the ball will get dirty, so that is why I will use this. I have previously used Gemini AI to generate me some seamless fingerprint textures that I could put on a ball. This is one of those images. It looks awesome. I don't know if I can just eyeball it and make the same kind of texture. This was the second one and this was the third one. Now I think I'll just go with something simple, and this one looks like it might be it. Now I'll simply scribble something on the ball that looks like a fingerprint when you move this around. I think this should be good for one of them. If I just continue, then the lines will get bigger and bigger, so maybe I'll just make a couple of them and then kind of mash them in. But before I do that, let me actually test if this one works, and if it does, how good it is. So I think this will actually work. So the only thing that I have to test out is, will this fade when I touch it a bunch of times? Well, not only fade, but will it smear? And it looks like it does, at least a little bit. So this is not the intention, at least not the way that I have envisioned. So the blue color does go off. So what I intend to do is making a bunch of fingerprints and then spraying this with a clear coat. And then I will just hope that the spray paint will stick to the ball and also glide smoothly over this contraption. So I think I basically made a trackball. So you do see this ball clearly. Wait a moment. So it took a while, probably maybe 20-ish minutes to finish with the markings. Then what I've done is I've used a transparent acrylic spray. This is just something that I had on hand. The only thing that it was required is that it was transparent. And let me maybe zoom in. Maybe you'll be able to see, but I doubt it, some spots where the light hits. Some tiny spots, so not from the markers, but basically from the spray. And maybe just using the spray, the transparent one, or basically any spray, if you wanted to change the color, would be enough. So the laser would bounce off of those imperfections, because I did not sand the spray. And now to see that this actually works, what I've done is I have taken the stator from the water pump that you have seen previously, basically cut all of the windings out with this handy little snipping tool. I then also snipped off every plastic piece on the inside, on both sides, and this side is now basically flush. And there is a reason for that. So now the ball goes on the top. I may still snip out these plastic pieces, I'll see, but for now I do not need to snip those. And what I have done is also I got myself a cheap mouse. It is a tiny mouse. It's this big of a mouse. So just get the cheapest mouse that you can get. And why is that? Well, because you do need the laser from the mouse. And why I have cut all of the button pieces? Well, basically because I will position the mouse like so. I just have to figure out how to cut this plastic and how I'll actually attach it. Now what this mouse has good, and I actually did not know this, is that it has a hole for a screw here, and the stator also has the hole, so this will line up perfectly. So the screw will just be able to go through here, and the other side, as you can see, these two holes are wide enough so I don't actually have to mess with the PCB, and it can sit just like so. And now if we take a look at the screen, so you can see the mouse pointer, I will not be moving this mouse. And now if I just use the ball, you can see that the ball actually moves. So we have up, down, left, right. So left, right, up, it's actually down, and down is actually up. But you can actually reverse the axis in Windows and maybe also Linux as well. So that will not be an issue. The only thing that I wanted to know is if this actually works, and it does. So the only thing that I need to do is somehow attach all of this to a piece of wood or something like that, and that will then sit on top of a button, a tiny button, a button that you can use for mice. Where was I? Ah, yes, the grommets. At least I believe this is what this is called. So it's a rubber grommet with a hole. So I will use a screw to go through these grommets. I have 3 hole-ish kind of openings. So this is where I will put the screws. And speaking of the screws, I used 3 screws and drilled them in a piece of wood. So basically it looked like so. I put the ball on the top and I used maybe 10 centimeter long screws. Why I've done that? Well, for painting. If you use something tiny, let's say a tip of a pencil, so it's tiny, and just the tip is touching the ball, you will have a very small area where the ball is actually not covered in the spray. So that is what I used. I used 3 screws, put the ball onto them, and sprayed away. How much did I spray? I sprayed lightly from all of the sides, and I've used, I think, 4 coats. So this should be good enough. And as you saw, it does work. Now the only thing that I have to do is somehow combine this with the mouse, something flat underneath all of this, put a button that looks similar to this one, just it doesn't have as high of a button, and then this will go beneath that. And how will I connect the button? Well, I can basically take out the left mouse button, so I could also use this button, but it does have just a tiny area to click, so this is not ideal. So I will use a different one that I have on hand, and maybe I will use multiple of them because I have no idea how this will actually behave. And what I may need to use is a cheap PCB that I will then solder the buttons on. And as for the wiring, well, basically I can just connect the wires to the same pins that this button uses, which are these 2. So yeah, that's the plan with this project, but this tracking mouse ball is just a part of the project that I am working on. But if you do have some billiard balls lying around and you want to turn them into trackballs, you can totally do that. You'll just have to figure out what the holder will be for you. In this case, I had a water pump stator that I could use, but if you have access to a 3D printer, maybe you can use that. So at the moment, this is a finished prototype. It does work. I still need to put it inside the housing, but that is a project on its own. So this is the best that I can show you at the moment. It moves fairly smoothly, though I don't know if making all of these squiggly lines made any difference, because the paint does have some particles, so maybe that would be good enough on its own, but the squiggly lines do fit the project, so that's just fine. And now let me zoom onto the monitor so that you can actually see the mouse movement. And what I don't have at the moment as well is the button, which is sandwiched down here. I still have to figure out how I'll actually connect all of that and also how I'll fixate all of this, because currently this is just multiple pieces moving in separate directions. So let's see, where is the mouse pointer? At the top. Now when it comes to trackballs and mouse movement, if I go to the left, in this case it goes to the left, goes to the right, but if I go forward, I would maybe expect it to go up. So in this case the movement is kind of like piloting a plane. So the y-axis in this case is reversed, but it also depends how you actually position this. So if I just position this around, so it would be like this. Then now the up is okay, the down is okay, but now I have the x-axis reversed. So when it comes to the trackballs, and at least on Windows, so it is Sakasa mouse app. I've used this link from Softpedia. It's pretty basic and does exactly what I want, so it reverses x and y axis. Now this is in Windows. Now when it comes to Linux, I'll actually have to take a look what the solutions we have on Linux. So we just have an exe file. Once you extract zip, launch it, and when I launched it, this was reversed by default. So let's see what I have enabled. So I have nothing enabled at the moment, and based on this ball position at the moment, I have to reverse the y-axis. So if I click apply, now when I move my mouse down, the pointer goes up, and when I move it forward, it goes down. So for this mouse, it's now reversed, but if I use this one, it's exactly as you would expect. When you go down, it goes down. When you move up, it moves up. And the left and right is intact. You can then reverse the x-axis as well, and even rotate it by custom degrees. Now when it comes to the project, let me just give you a quick update. I've done basically everything when it comes to the UI.
Mission start confirmed. Biosignature acquired. Identity lattice active. Archiving digital footprint. Digital trace archived. Don't worry, your enemies will remember it.
So basically I just have a bunch of images to put in.
Ooh, edgy. Someone's mysterious.
And the rest of it is done.
You'll terrify at least one person.
So the bio is now generated randomly. I also have a lot more attributes, and also these attributes can appear in the bio. As for the older profiles like this one, if they were generated when I did not have this defined, then everything is not available. I also have the deletion profile now working.
Final stage. Enter password to confirm deletion. Nice try. Password denied.
And everything I believe has 10 sounds, different sounds.
Back away from the button! Warning, unauthorized override attempt. One last chance to turn back.
Oh yeah, one thing that I then have to disable is the simulate scan button once I have the project finished. Currently I don't have anything to scan with, so this is the simulation. I can cancel, it will just give a mocking voice so that you thankfully cancelled, and if you simulate scan,
Delete, delete.
it also gives you a mocking voice because you can't actually delete anything. That's it for the trackball and a quick update for my digital project. If you'd like to see it, subscribe to the channel, and we'll do something else in the next one.